All right, so you're going to watch this video clip. We've been talking about the permafrost and the tundra as being different biomes. So you're going to watch this video clip. I need you to write down some facts about permafrost, okay? Maybe about what it is, what impacts it has. Basically 3 different facts. Okay, it's up to you. What? The Kool-Aid is not for you. That's for bio. All right, so you heard about permafrost on that video clip. What do we find out about permafrost? What is it? Right, frozen ground, and it remains frozen for 2 or more years. Why are they concerned about it thawing? Okay, so it releases carbon dioxide and methane, and those are greenhouse gases, right? And so as the climate warms, it releases more of those gases, which causes the climate to warm even more, which would release more of those gases. Would that be an example of a positive or negative feedback loop? Positive, right? Because it's that snowball effect, okay? Anything that makes it bigger and bigger and bigger, and that snowball, snowball, snowball would be an example of a positive feedback loop. So we've been talking about different biomes, right? And permafrost is big with the tundra, okay? We're going to kind of shift gears. This is my actual... I might have a question or two on the test on it, but we'll cover it again in when we get to chapter 10. But since we have extra time, I just wanted to look at it today because it's a really big topic that's covered in the AP test, okay? You got back your multiple choice questions. Those are a completion grade, but I did actually mark which ones you got wrong. Remember, this is the same test bank that questions for your test come from. So some of these might appear on your tests. So when we talked about studying tips, study some of these questions, right? Cover up the answers, see if you can still get them right, because some of those might appear on your test, right? So today we're going to be talking about ozone. That's why you have marshmallows on your desk. So what I'm going to pass out to you is the worksheet. So you're going to get the worksheet here, and then we will we'll read some background information, and then we're going to play with the marshmallows, basically, is our plan. Reminder, you have a test Thursday. I'm holding a review tonight on line 67 from molecules are found in the stratosphere. The ozone layer is an important protective shield for life on Earth, filtering out more than 99% of the UV rays from the sun before they reach us. Ultraviolet rays can cause sunburns. Certain chemicals cause destruction of the ozone, which increases the ultraviolet radiation coming down to the surface of Earth. Some scientists predict that increasing ultraviolet radiation will increase the incidences of skin cancer, immune deficiencies, and cataracts. What part of the body do cataracts affect? Your eyes, right? So more UV light is going to damage the your eyesight, and so that's why they think it'll increase cataracts. In 1987, the U.S. EPA, Environmental Protection Agency, estimated that 40 million Americans will get skin cancer during the next 88 years, and of those, 800,000 will die. So ozone gas in the stratosphere forms when oxygen molecules interact with UV rays from the sun. The amounts of ozone in the stratosphere are changing all the time. Under normal circumstances, ozone is continuously being destroyed and regenerated by the sun's ultraviolet rays. So it says, see the picture above. So on that picture, you see it says ozone formation naturally from lightning. Lightning or UV rays from the sun will strike an oxygen molecule. So oxygen is two oxygen molecules together, and it splits it apart. All right. Now, if one of those oxygen molecules or atoms finds another O2, it can combine to form O3. So we're just getting ozone, which is O3, and it can be destroyed just as easily. It's constantly getting recycled. So it's constantly getting destroyed and remade, and the amounts of ozone that exist in the ozone layer are roughly about the same at any given time. The seasons of the year, changing winds, and even sunspots affect ozone levels. Harmful pollutants in the air can also affect ozone by forcing ozone to break down faster than it can rebuild. No actual holes in the ozone protecting the Earth have been found. This is important. So they're not actually holes, right? It's just a decrease in the amount of ozone molecules in that layer. So it says these holes are not completely empty of ozone, but the ozone concentrations in these areas are lower than normal, allowing more UVB rays to reach the Earth's surface. Ozone holes currently exist over Antarctica, the northern half of the U.S. into Canada, and northern Europe and Tibet. The only practical approach to stopping the destruction of the ozone layer is to reduce the amount of human-created pollutants that contribute to its depletion. Efforts to protect the ozone layer now involve many different nations and industries. The most common ozone-destroying pollutants are in a class of chemical compounds called chlorofluorocarbons, CFCs. So what three elements do chlorofluorocarbons have in them? Based on the word, what do you see? What from the periodic table? Chlorofluorocarbons. Carbon. Okay. Chloride. What? Fluorine. Okay, so fluorine, chlorine, carbon. Okay. And these chlorofluorocarbons were once used in air conditioner, refrigerator coolant, lubricants, cleaning solvents, plastic foam manufacturing, and aerosol spray propellants. Okay, a lot of big words there. They were mainly used for those gases up into the atmosphere. All right, so it says here, engineers are inventing and designing new technologies to help save the ozone and stop its reduction due to harmful CFCs. However, alternatives like halons and halogens are not harmless. Many still cause the breakdown of ozone molecules in the stratosphere. So we have some alternatives, but they aren't completely harmless, and some of them still act like these CFC molecules. So what I want you to do is go ahead and answer, take a couple minutes and answer those pre-lab questions. All right, so ozone, what is it? Molecule that what? What does it look like? How many oxygens? Three. Okay, so it's got 3 oxygens and it breaks UVB rays. What layer of the atmosphere is it found in? Stratosphere. Okay, why is it important? And then you will have an ozone molecule which looks like a V or whatever. Okay, so it's got 3 molecules. So you guys are going to have different jobs in your group. You will have some extra toothpicks in here. That's fine. You will need those toothpicks. All right. I'm going to show you your groups. I need you to get around a paper that has marshmallows in it. And I will tell you what to do next. So here are your groups. They're big groups. Okay, so go find your group. It's okay if not everyone in your group is there. Why are you underlined? Because there's free it's a free service, and they want to make you click on the links to go to ads. All right, find your group. You gotta go to the next group program. All right, so here's the deal, everybody. You need to there goes my microphone. You need to find people who have different jobs. Okay, so 2 people are going to be ozone makers. Okay, so pick 2 people right now to be ozone makers. Okay, here's what the ozone makers do. conditions. So on your chart here, under normal conditions, recording, you can skip the numbers here. What you should see is that the amount of ozone is decreasing, especially with the CFC destroyers. So I need you to finish number 8 and 9, and then the pre-lab questions, which we went over, and then turn those into me.